Okay, I guess you were practicing this. Shh. You're practicing this right now. Again, I want to bring you back to the idea that prior to this class, or prior to your time in Algebra 2, if you would have seen f of x equals x to the third and know that it looks like that, you maybe would have said, well, that looks very complicated to try and graph. But it's really not that bad. So let's finish off these last two. What are the transformations that I have to perform on that? Up 4, good. Right 1, reflect over the x-axis. And we actually perform them in this order. We technically go right 1, then reflect over the x-axis, then up 4. That's technically the order that you go. So, you work your inside out, like order of operations. And the last one, what's the, what's that? What's the parent function? Absolute value of x. Looks like that. And what are the transformations here? Okay, it flips. Is it 5 to the right, 5 to the left? What is it? I take the inside and set it equal to 0. And if you solve, you get x is 5. So it moves to the right 5 and it's upside down. Piece of cake upside down. How's that? Okay, so you guys, Julia and Tyler, you guys can look to see kind of where Bailey and Tara are in terms of where your notes are so you know where to go. But I want you guys to know that I don't want to graph stuff like that all throughout pre-calc. That's a little too easy to graph. I want to graph stuff that looks like this. Okay? And what I want to do is I want to take that, I want to stretch it, I want to compress it, I want to move it to the left, I want to move up, down, all over the place. So you're going to take that type of graph, which this is y equals the sine of x. That's super. So then what you'll do is you'll actually take this and you'll make it look something like this instead, okay? It'll be, compressed, it'll move up, it'll move over, and that's exciting because actually that models things in real life. For example, my voice travels to you as a wave, right? Sound. So that stuff's very useful. So just realize that we want to use this to do more difficult stuff. So, okay. Vertical, stretching, and shrinking. Here we go. F of x maps to a times f of x. If you see a number in front of the function, it will be a vertical stretch, or it will be a vertical shrink. Think about the value of a that you put in front of a function. What would cause it to stretch and what would cause it to shrink? Negative flips it, right? Fraction. So if a is greater than 1, it's a vertical stretch. If a is between 0 and 1, it will shrink it by a factor of a. Any questions? Okay. Horizontal. Notice the a is on the outside, right? Outside is always vertical. If we have a function that maps to f of a times x, poor handwriting there, f of a times x, this would be a horizontal. shrink or a horizontal stretch. Now, it's opposite of what it was before. So this time, if A is greater than 1, it's a horizontal shrink. If A is between 0 and 1, then it's a horizontal stretch. And this time it's by a factor of not A, but 1 over A. So anytime you have something happening on the inside, horizontal, it's different than what you think, and it's a little bit more complicated. But we'll practice this, and you'll be very good at it. The next question we have, I promise you'll have one like that on the test. So these are the notes. We're going to use these in order to perform the next problem. You need to copy this shape down. The coordinates are -4, 0, -2, 2, 0, -4, and 2, 0. You can copy that shape down, and we're going to perform transformations to that shape. And again, I promise you will have this type of question on the test. So this is just curiosity. So if I say, like, I promise this is going to be on the test, does anybody, like, mark it? So you do start? Okay, you start it, you start it. So for those of you who didn't start, you didn't start because you know I'm going to probably put it on the study guide anyway? Or, okay, I was just curious. I remember being in classes this summer, and if the professor, I think he maybe said that once, and it was like, that was just gold. And you just take a big highlighter and it's like, know this. And he didn't actually put it on the test. That's kind of mad. Anyway, okay. What? All right, okay. All right, let's pretend all is well. Okay, you guys got that shape? Let's try now. This is y equals 2 times f of x. So, is this a shift or is this a stretch? Is it vertical or horizontal stretch? Vertical by a factor of 2. Does that impact the x values or the y values? If it's a vertical stretch, it will impact the y values. So what we can do is, as you look at these coordinates, do we need to change -4 at all? No. What we need to do is we need to multiply the y values by 2. So the new coordinates of this shape will, instead of having -4, 0, I will have -4, 0, because it just gets multiplied by 2. It's still 0. So that's a coordinate right there. Instead of -2, 2, I will have -2, 4. Instead of 0, -4, I have 0, 6, 8. Instead of 2, 0, I still have 2, 0. And then I connect my dots. Does that look like? Does it look like it was stretched vertically? Does it look like anything happened horizontally? No, if you look from the first point to the end point, they're still, that same distance apart. So nothing really happened horizontally. So that's good. Okay, the second one, f of 0.5x plus 1. What's happening there? Horizontal. It says in your notes, if a is between 0 and 1, it's a horizontal stretch by a factor of 1 over a. What is 1 over a in this situation? What's 1 over 0.5? 2. So I stretch it by 2 horizontally. After I stretch it by 2 horizontally, so again, our factor here is 1 over 0.5, which is 1 over 1/2, which is 2. So that's my factor. I'm going to stretch it horizontally. And then after we stretch it horizontally, what does this plus 1 do? Right, so the x values, I will do what to them? Multiply them by 2, and the y values, I will add 1. So that's what I'm going to do here. Okay, so let's do that, get our new shape. So I have negative 4, 0. I multiply by 2, and I get negative 8, 0, and then I add 1. Negative 8, 1. Negative 2, 2. Negative 4, then add 1 to get 3. Negative 4, 3. Good. 0, negative 4. 0, negative 3. And the last one, 2, 0. Multiply the x value by 2 to get 4. So 4, 0. Then I add 1 to the y value to get 4, 1. And that's my new shape. Okay, so that, does that look like it was stretched horizontally? Yeah, so it looks like we did a good job there. Okay, good. Good, 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 good. Okay. Oh boy, y equals negative f of x minus 1 minus 3. Are there any stretches or compressions happening there? No. So what's happening? Okay, I have what type of a reflection? Vertical or horizontal? It's on the outside, so it's vertical. What's the minus 1 do? Horizontally by 1, what does the minus 3 do? Vertically down 3 units. So I'm going to perform it in this order. I start on the inside, I work my way out. First, I go right 1. Then the negative flips it over the x-axis. Then I subtract 3. I move down 3 units. Let's try it. Negative 4, 0. I move it right 1 to negative 3, 0. I flip it over the x-axis. It's still negative 3, 0. And then I subtract 3. It becomes negative 3, 3. I'm sorry, negative 3, negative 3. I find it hard to do this just looking at the coordinates. I have to really look at the drawing. So, negative 2, 2. I go right 1. Then I flip it over the x-axis. So negative 1, negative 2. And then I subtract 3. So I have negative 1, negative 5. Zero, negative 4. Right 1. Flip it over the x-axis. That'll make it 1, positive 4. Then I subtract 3 units, and I'll be at 1, 1. And finally, 2, 0. I move it to the right 1. I flip it over the x-axis, which is still 3, 0. And I move it down 3 units to 3, negative 3. And that shape should look identical to the previous one, just shifted right 1, down 3, and be upside down. What do you think? I think we did that. Ready for the last one? Last one's the toughest. What happens there? Flips horizontally over the y-axis. Good, that's the first thing I have to do. Vertical stretch by a factor of 2. Then I shift it up 2. So f of negative x, that will switch the x values, and I multiply the y values by 2, then I add 2. So I'm going to actually write down what I do here. Switch x values. I take my y values and I multiply them by 2, and then I add 2. That's actually what's happening, right? So let's look at negative 4, 0. Switch the x value, I have 4, 0. Multiply y by 2, I have 4, 0. Add 2, I have 4, 2. Now I do negative 2, 2. Switch the x value. 2, 2. Multiply the y value by 2. 2, 4. Add 2. 2, 6. This one. 0, negative 4. Flip it over the x-axis. 0, negative, or flip it over the y-axis. Excuse me. Yep, still 0, negative 4. Multiply by 2. 0, negative 8. Add 2. 0, negative 6. And finally, the last one. 2, 0. Switch the x value. Becomes negative 2, 0. Multiply the y value by 2. Negative 2, 0. Add 2. Negative 2, 2. Connect my dots. Does that look like it's reflected over the y-axis horizontally and then taken care from there? Yes. Oh boy, we're almost out of time. Looks like we got to do even and odd tomorrow. Flip over to the backside. Let's do the very last. Where am I? Let's do example 5. We'll have to quick do the even and odd tomorrow, then you'll have time to work. We're just a little bit behind. I gave you too much time. Okay, so now let's try to actually write a function. It says a function is given and the indicated transformations are applied to its graph in the given order. Write the equation for the final transformed graph. So if f of x, if the parent function is the absolute value of x, how could I write a new one that's shifted 3 units left, or I'm sorry, shift up 3 units and 9 units left? What? Absolute value of x plus 9, good. Plus 3, good. So the plus 9 is the 9 units left. The up 3 is the plus 3 at the end. Good. F of x equals x to the third. I need to reflect it over the x-axis, horizontally shrink it by a factor of 4, and shift it down 3. So if I need to shrink it by a factor of 4, if I put a 4 in front of the x, will that shrink it horizontally? Look at your notes. If I put a 4 in front of it, is 4 greater than 1? Yeah, so that'll be a horizontal shrink. Okay? So I want to shrink it by a factor of 4 and shift it down 3. How do I reflect it over the x-axis? What do I have to do? A negative in front, right? So g of x is, I put the negative in front, and if it's a horizontal shrink, I put the 4 on the inside, and I cube that. Then what about the shift down 3? Minus 3. Okay, we got to get through those last couple tomorrow. It'll take us about 5 minutes, and you'll have the rest of the day to work. Your homework is to finish up that parent function worksheet. That'll be due test day.